Hello everyone, myself Mukesh Kumar Tiwari from LPM Public School. Student, today we will talk about for the some special reaction of the carboxylic acid. So let me explain the reaction. The first reaction is by the reaction of carboxylic acid with SOCl2, that is the thionyl chloride, PCl3 and PCl5. Clear?
All the partial features and molecules are reminded that the homework of output must be filled with the homework regularly.
RCOOH.
Period assignments to be maintained.
Clear? This is the carboxylic acid, and when this carboxylic acid is treated with the thionyl chloride, then it will form RCOCl plus SO2 sulfur dioxide plus HCl. Clear? This is the final product, and this is known as acid chloride. This is the acid chloride. Clear? Similarly, when the carboxylic acid is treated with the PCl3, then we get 3RCOCl plus H3PO3. This is the orthophosphorus acid and acid chloride. When this carboxylic acid is treated with the PCl5, then it will form RCOCl plus PuCl3 plus HCl. Clear? So this is the first reaction. Now the second reaction, by the reaction of carboxylic acid with P2O5 or concentrate H2SO4. When the carboxylic acid is heated in the presence of phosphorus pentoxide or the concentrate H2SO4, anhydride is formed. For example, when the two molecules of ethanoic acid is heated in the presence of phosphorus pentoxide or concentrate H2SO4, then ethanoic anhydride is formed as a major product after the removal of this is the ethanoic anhydride, or the second name of this compound is the acetic anhydride. Clear? So when the carboxylic acid is heated in the presence of this reagent, that is the phosphorus pentoxide or the concentrate H2SO4, ethanoic anhydride or acetic anhydride is formed after the removal of one water molecule. Clear? How this reaction is occurred? You can write like this: CH3 C CS3. This is the second molecule, and this is heated in the presence of phosphorus pentoxide. Then from here one hydrogen and one OH group, clear, are removed, and we get the compound like this: CS3, C, double bond O, single bond O, single bond C, double bond O, single bond CS3 plus H2. Clear? This is the ethanoic anhydride, and this ethanoic anhydride can also be written like this. Clear? So this is the explanation for the complete reaction of the compound. Clear? Now I will talk about for the next reaction compound. Reaction with ammonia, that is the formation of amide. The reaction of ammonia, that is the formation of amide. This is the reaction number 3rd. Reaction with ammonia, NH3. Clear? Suppose an acid are given RCOOH, and when this acid is treated with the ammonia, then it will form the ammonium acetate like this. And when this ammonium acetate is heated, then one of the water molecule is removed here, and we get a compound which is known as amide. This is amide. Yes? Suppose an example are given to you. This is the acetic acid, and this acetic acid is treated with the ammonia, then it will form ammonium acetate, and when this ammonium acetate is heated, then water molecule is removed, and it will change into the CS3CONH2. This is known as acetamide. The name of this compound is acetamide. Clear? This is the acetamide. Now come on, the second reaction. Acetamide is formed. Suppose any compound are also given to you like this type, then how will you complete the reaction? Clear? Suppose a reaction are given to you RCOOH, single bond COOH, and this compound is treated with the ammonia, then heated, which compound will form? Clear? So how will you complete the reaction? You can write the product COOH, single bond COOH. When this compound is treated with ammonia, then it will form like this: COONH4 and COONH4. Clear? And when this will be heated, it will change into the amide CONH2, single bond CONH2. When we heat the compound again, then we get a new compound which is known as phthalimide, like this. This is the phthalimide. CHTHA alamide. Here ammonia is removed. After heating this compound, ammonia is removed and we get the alamide. Clear? Now come on. We have talked about another equation, reaction. The reaction name is HBZ. HBZ reaction. Very important reaction on. Mark this reaction. HBZ. The full form is Hell-Volhard Zelensky. Hell-Volhard Zelensky reaction. In this reaction, the corresponding carboxylic acid is treated with the halogen or chlorine in the presence of the red phosphorus. Then alpha hydrogen of the carboxylic acid is removed one by one when treated with the halogen. Clear? Suppose we considering about the SBZ reaction, and this is the acetic acid are given, and this acetic acid is treated with the red phosphorus and chlorine. Clear? So this will be the alpha carbon, this will be the alpha carbon, and one of the alpha hydrogen and one of the chlorine will form HCl, and here HCl is removed and we get the chloroacetic acid. But even the reaction will not stop when we take a greater amount of the chlorine. Clear? Again, the one of the alpha hydrogen atom from here and one HCl from here, HCl will remove. We get the Cl2CHCOOH. The reaction will occur till the whole hydrogen or the total hydrogen or alpha hydrogen will not remove. It will be continued, and the reaction is considered as the Hell-Volhard-Zelensky reaction or HBZ reaction. Here, this is the acetic acid. This is the alpha chloroacetic acid. Or you can also write here monochloroacetic acid. This is the dichloroacetic acid. And this is the trichloroacetic acid. Clear? So this is the SBZ reaction. Now come on, we talk about for the another electrophilic substitution reaction in case of the benzoic acid. As we know that in electrophilic substitution reaction of the aromatic compound, we consider the halogenation, nitration, sulfonation, Friedel-Crafts reaction, etc. Clear? So we talk about for electrophilic substitution reaction in benzoic acid. Electrophilic substitution reaction in benzoic acid. Clear? So only we talk about for the three electrophilic substitution reaction, that is the halogenation, sulfonation and nitration, one by one. Clear? When the benzoic acid is treated with the chlorine in the presence of iron and in the absence of light, sunlight, we get the metachlorobenzoic acid. We get metachlorobenzoic acid and HCl will be the side product. Clear? Because benzoic acid is the meta-directing. In benzoic acid, the carboxylic group is the meta-directing group, and the incoming new atom or group will occupy its meta position. So we get the metachlorobenzoic acid. When the benzoic acid is treated with the concentrate HNO3 and the concentrate H2SO4, we get the meta-nitrobenzoic acid. Meta-nitrobenzoic acid after the removal of the one water molecule. Similarly, when we treat the benzoic acid in the presence of concentrate H2SO4, we get the metasulfonic benzoic acid, like this. So this is the electrophilic substitution reaction in benzoic acid, and this is all about the reaction related to the carboxylic acid as well as the benzoic acid. Now I will talk about for the next topic in my next video. Thanks a lot.